And now in this lecture we'll answer two questions. In the first question we find out the radius of this circle, and in the second question we find out the area of this semicircle APB. So we start with the first question. In the drawing we have a circle. This is line segment CP, this is equal to 12 units in itself. This is line segment AP, this is equal to 4 units in itself. This is line segment PB, this is equal to 4 units in itself. This is angle CPB, this is equal to 6 degrees inside. Again, our task is to find out the radius of this circle. So first of all, it is given as a question that AB is a straight line. So if you focus on the upper side of the straight line AB at point P, here the sum of the angles must be equal to 180 degrees according to all three. All three said that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AB at point P? We have this angle that is equal to 60 degrees inside, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to all three. Therefore, this missing angle must be equal to 120 degrees in its size. The next step, we join point C and A together by a straight line. We join point C and B together by a straight line. When doing those constructions, we're going to do three triangles. This is triangle APC, this is triangle APCB, the big triangle ABC. So first of all, when you implement the law of cosines on all the three triangles. So a bit quickly on the law of cosines. The law of cosines is true in any triangle. This is triangle ABC that could be any triangle. Side AB, this triangle ABC equals to A units in itself, side BC equals to C units in itself, side AC equals to B units in itself. This is angle BAC equals to 30 degrees in its size. And in this triangle ABC that could be any triangle, the following equation is true. C square equals to A square plus B square minus 2 times A times B times cosine theta. Again, C square equals to A square plus B square minus 2 times A times B times cosine theta. So we can implement the law of cosines. This triangle ACP. And again, we will implement the law of cosines in this main triangle APC. So, according to the law of cosines, we'll choose angle theta as 180 degrees, this angle APC. So according to the law of cosines, AC square again triangle ACT according to the law of cosines, the following equation is true. AC square equals to AP square plus CP square minus 2 times AP times CP times cosine 120 degrees. And again, in this green triangle APC, according to the law of cosines, the following equation is true. AC square equals to AP square plus CP square minus 2 times AP times CP times cosine 120 degrees. AC is the missing side, so leave it as it is. So it is AC square equals to AP square. AP is 3, therefore AP square is 3 squared, that is 9, plus CP square. CP is 12, therefore CP square is 12 squared, that is 144. Minus 2 times AP is 3, times CP is 12, times cosine 120 degrees. Cosine 120 degrees is minus 1/2. So today we found out that AC square equals to 9 plus 144 is 153. Minus times minus is plus, so this expression is a positive expression, and we have minus in the numerator, minus in the denominator, so we have 2 in the numerator, 2 in the denominator, so 2 get cancelled. So this expression in total equals to 3 times 12 is 36, so it is plus 36. So in total we found out that AC square equals to 153 plus 36. So AC square equals to 153 plus 36 is 189. AC square equals to 189. So here we take a look out of this equation, and finally we get that AC equals to the square root of 189 . This is side AC, that equals to 189 units in its, the square root of 189 units in its length. So write it down. AC equals to the square root of 189 units in its length, and AC square equals to 189. Likewise, we implement the law of cosines in this triangle, triangle PBC, the white triangle, triangle PBC. So we choose angle theta as this angle CPB, that equals to 6 degrees. So we have CB square, according to the law of cosines, CB square equals to CP square plus PB square minus 2 times CP times PB times cosine 6 degrees. Repeat again, in this white triangle CPB, according to the law of cosines, according to the law of cosines, the following equation is true. CB square equals to CP square plus PB square minus 2 times CP times PB times cosine 6 degrees. CB is the missing side, so we leave it as it is. So it is CB square equals to CP square. CP is 12, therefore CP square is 12 squared, that is 144. plus PB squared. PB is 4, therefore PB squared is 4 squared, that is 16. Minus 2 times CP, that is 12, times PB, that is 4, times cosine 60 degrees. Cosine 60 degrees is 1/2. So we find out that CB squared equals to 144. 144 plus 16 is 160. We have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. After we cancel 2, we have here minus 12 times 4 is minus 48. So in total we should find out that CB squared equals to 160 minus 48, that is 112. CB squared equals to 112. Here we take a root out of this equation and find out that CB equals to the square root of 112 units in its length. This is side CB. This is equals to the square root of 112 units in its length. And CB squared equals to 112. In the next step, we'll implement the law of cosines. This big triangle ABC. The big triangle ABC consists of those two small triangles. So in the big triangle ABC, but before that, we will define this angle BAC is alpha. So angle theta is angle alpha in our triangle ABC. So in the big triangle ABC, according to the law of cosines, CB squared equals to CA squared plus AB squared minus 2 times CA times AB cosine alpha. And again, in this big triangle ABC, according to the law of cosines, the following equation is true. CB squared equals to CA squared plus AB squared minus 2 times CA times AB times cosine alpha. We already found out that CB squared equals to 112 and it is equals to CA squared. CA squared is 189 plus AB squared. AB in total equals to AP, that is 3, plus PB, that is 4. So in total, AB equals to 3 plus 4, that is 7. Therefore, AB squared equals to 7 squared, that is 49. This is plus 49. Minus 2 times AC equals to the square root of 189 units in its length times AB. AB equals to 7. So in total, if you want to know that 112 equals to 189 plus 49 minus 2 times 7 times square root of 189. So 112 equals to 189 plus 49 is 238 minus 2 times 7 is minus 14, so the total expression equals to minus 14 times square root of 189. So in total, if you know that 112 equals to 238 minus 14 times square root of 189. Here we'll subtract 112 from this equation. So in this end of the equation we have nothing, that is to say 0. While on the other side of the equation we have 238 minus 112 is 126. And this equals to 136 minus 14 times square root of 189 times cosine alpha. Here I forgot cosine alpha. So this times cosine alpha. So here we add to this equation 14 times square root of 189 times cosine alpha. And get that 14 times square root of 189 times cosine alpha equals to 126. Here we divide this equation by 14. And you get that here 14 get cancelled. So in this side of the equation we left only with square root of 189 times cosine alpha. And on the other side of the equation we have 126 over 14 is 9. So in total we found out that square root of 189 cosine alpha equals to 9. Here we divide this equation by square root of 189. And we get that cosine alpha equals to 9 over square root of 189. So cosine alpha equals to 9, and here we have square root of 189. We substitute 189 by 21 times 9, which is 9 times 21. The square root of 9 is 3, so we take 9 out of the root. So it is 9 over 3 times square root of 21. Here we divide both the numerator and the denominator of this expression by 3. We get that 9 over 3 is 3 and 3 over 3 is 1, so here we left only the square root of 21. So in total we found out that cosine alpha equals to 3 over square root of 21. So again, cosine alpha equals to 3 over square root of 21. We have the trigonometric identity. Here TA is a version for trigonometric identity that states that sinus square alpha plus cosine square alpha equals to 1. Here we subtract cosine square alpha from this equation. We get that sinus square alpha equals to 1 minus cosine square alpha. Here we take a root out of this equation, and so you get that sinus alpha equals to the square root of 1 minus cosine square alpha. We already found out that cosine alpha equals to 3 over square root of 21. Cosine alpha equals to 3 over square root of 21. Here, let's square this equation. We get that cosine square alpha equals to 3 square is 9 over 21. The square root of 21 square is 21. So we found out that cosine square alpha equals to 9 over 21. So we substitute cosine square alpha in this equation by 9 over 21. And we get that sinus alpha equals to the square root of 1 and minus and cosine square alpha equals to 9 over 21. So we found out that sinus alpha equals to 1 and the square root of 1 minus 9 over 21. So sinus alpha equals to the square root. Here we multiply 1 by 21 and then we divide it by 21 in order to overcome factor of this number. So it is 21 minus 9 over 21. We multiply 1 by 21 and then we divide it by 21, so we change nothing. It is allowable to multiply anything by 1. So in total, if you found out that sinus alpha equals to the square root of 21 minus 9 is 12 over 21. Here we divide both the numerator and the denominator of this number by 3. We get that 12 over 3 is 4 and 21 over 3 is 7. The square root of 4 is 2. So this expression equals to 2 over square root of 7. So we found out that sinus alpha equals to 2 over square root of 7. And we also found out that CB equals to the square root of 112. CB, the length of line segment or side CB, is equal to the square root of 112 units in its length. So, in the next step, we will implement the law of sines, the big triangle ABC. Repeat quickly on the law of sines. Actually, the law of sines is true in any triangle. So this is triangle ABC that could be any triangle. The length of side AB is C units. Side AC equals to B units in itself. Side BC equals to A units in itself. This is angle BAC. This is equals to capital A degrees according to definition. This is angle ACB equals to capital C degrees. And this is angle ABC equals to capital D degrees to capital B degrees in its size. So, and this triangle ABC is inscribed by this circle, and the radius of this circle is R. So according to the law of sines, the following equation is true. A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. And R is the radius of this circle that blocks triangle ABC. triangle ABC is described by this circle. And again, according to the law of sines, the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. So we can implement the law of sines in our drawing. The triangle ABC is described by this circle. Why triangle ABC is described by this circle? Because of the fact that all the three vertices of triangle ABC lie on the circle itself. So, according to the law of sines, we get that we implement the law of sines in triangle ABC. So according to the law of sines, CB over sinus alpha equals to 2R. And again, according to the law of sines, in triangle ABC, the following equation is solved. CB over sinus alpha equals to 2R. CB is equal to 112. And we already found out that sinus alpha equals to 2 over square root of 7. This equals to 2R. And again, today we found out that according to the law of sines, triangle ABC, CB over sinus alpha equals to 2R. CB is equal to 112, sinus alpha is 2 over square root of 7, this is equals to 2R. Actually, 112 is 16 times 7, so 712 was 16 times 7. Or 2 over square root of 7 equals to 2R. The square root of 16 is 4, so we'll take 16 out of the root. So it is 4. Inside the root we left only 7 over 2 over square root of 7 equals to 2R. Here we remove square root of 7 in the numerator and 2 in the denominator, and we get that 4 times square root of 7 times square root of 7 over 2 equals to 2R. 4 over 2 is 2, so we have 2 times square root of 7 times square root of 7 equals to 2R. Here we divide this equation by 2, and finally get that square root of 7 times square root of 7 equals to R, or R equals to 7. 7 units in itself. Actually found out that the radius of this circle, that is the radius that we are looking for in this question, is equal to 7 units in its length. So finish with the first question. In the next step I will present you the second question and answer the second question of this lecture. second question, our task is to find out the area of this semicircle APB. So in the moment we have semicircle APB. This is line segment PC. This is equals to 21 units in its length. This is line segment AC. This is equals to 7 units in its length. This is line segment PQ. This is equals to 16 units in its length. And our task is to find out the area of this semicircle APB. We define the radius of this semicircle as x. So the diameter AB equals to 2x. AB, the diameter is 2x. Therefore, CB, the missing line segment CB equals to AB minus AC. So the norm CB equals to AB minus AC. So CB equals to AB is 2x. Minus AC, AC is 7. So if you want to know that CB equals to 2x minus 7 units in its length. Line segment CB equals to 2x minus 7 units in its length. In the next step, we will complete this semicircle to a circle. And we'll extend line segment PC until it touches the circle. We define the touching point of the extended line segment PC with this circle. This point is point M. So here we can implement rule 65 in our drawing. We just click it on rule 65. Rule 65 is true in any circle, so this circle could be any circle. According to rule 65, if chord AB intersects with chord CD at point O, or then the following version is true. AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. Repeat again. In the drawing, we have a circle. This is called AB that intersects with chord CD at point O. So in this drawing, the following version is true. AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can implement rule 65 in our circle. In our circle, we have this is called AB that intersects with chord PM at point C. Again, chord AB intersects with chord PM at point C. And therefore, so now, in our drawing, we have chord AB intersects with chord PM at point C. The intersection point of chord AB with chord PM occurs at point C. And again, now we're going. Chord AB intersects with chord PM at point C. So therefore, according to Rule 65, the following equation is true. AC times CB equals to PC times CM. And again, according to Rule 65, the following equation is true. Because of the fact that chord AB intersects with chord CM, because of the fact that chord AB intersects with chord PM at point C, the following equation is true. AC times CB equals to PC times CM. AC is 7 times CB. CB is 2x minus 7. And it equals to PC. PC is 21 times CM. We define CM as A. So CM is A according to our definition. So in total we found out that according to Rule 65, 7 times 2x minus 7 equals to 21 times A. Here we divide this equation by 7 and get that here 7 get cancelled. We left only with in this side of the equation we left only with 2x minus 7. Here in this side of the equation we have 21 over 7, that is 3. So in total this expression equals to 3a. So in total we found out that 2x minus 7 equals to 3a. In the next step, we will join points Q and M together by a straight line. By joining points Q and M, we can determine the right triangle PQM. This is a right angle. So angle MPQ is defined as a peripheral angle and it is equal to 90 degrees in its size. So peripheral angle MPQ, that is the right angle, subtend on chord QM. So we can implement here Rule 5. So I'm going to click on Rule 5. Rule 5 is true in any circle. So this circle could be any circle. According to Rule 5, any peripheral angle that is equal to 90 degrees in its side must subtend on the diameter of the circle. So in the moment we have a circle, this is peripheral angle MAN that is equal to 90 degrees in its side, and therefore peripheral angle MAN must subtend on the diameter of the circle. Peripheral angle MAN subtend on chord MN, that is the diameter of the circle. So according to Rule 5, any peripheral angle that is equal to 90 degrees inside must subtend on the diameter of the circle. So we can implement Rule 5 in our drawing. Because in our drawing, this is peripheral angle MPQ that is equal to 90 degrees inside, and therefore according to Rule 5 must subtend on the diameter of the circle. Peripheral angle MPQ subtend on chord QM, and therefore chord QM must be the diameter of this circle according to Rule 5. So this is called QM, this is the diameter of the circle according to Rule 5. Indeed, chord QM is the diameter of the circle because of the fact that chord QM passes for the center of the circle. And we know that any chord that passes for the center of the circle must be the diameter of the circle. We know that the diameter of the circle is 2x. So QM is the diameter of the circle, therefore it equals to 2x units in its length. So in the next step, we'll implement the Pythagoras theorem on this right triangle times PQM. So according to the Pythagoras theorem, on this big right triangle PQM, according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this right triangle PQM, here by PT is the equation for Pythagoras theorem. So according to the Pythagoras theorem, this triangle MPQ, the following equation is true. QM squared, that is the square of the hypotenuse, QM squared equals to PQ squared plus PM squared. And again, this big triangle MPQ, according to the Pythagoras theorem, the following equation is true. QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. QM is 2x, therefore QM squared is 2x squared. And it equals to PQ squared. PQ is 16, therefore PQ squared is 16 squared, that is 256. Plus PM squared. PM in total is 21 plus 8. Again, PM in total is PC, that is 21, plus CM, that is 8. So in total PM is 21 plus 8, therefore PM squared is 21 plus 8 squared. So in total, if you found out that 2x squared equals to 256 plus 21 plus 8 squared. But we already found out that 2x, here we'll add 7 to this equation. And we get that 2x equals to 3a plus 7. 2x equals to 3a plus 7. Therefore, we can substitute 2x in this equation by 3a plus 7. So it is 2x squared, so it is 3a plus 7 squared equals to 256 plus 21 plus 8 squared. Here we'll open the brackets of this expression and we get that 21 plus 8 squared equals to 21 squared, that is 441 plus 8 squared plus 2 times 21 times 8, that is 42a. So today we should find out that 3a plus 7 squared equals to 256 plus 441 is 697 plus a squared plus 42a. So if you found out that 3a plus 7 squared, 3a plus 7 squared equals to 697 plus a squared plus 42a. Here we'll open the brackets on this side of the equation and we get that 3a plus 7 squared equals to 3a squared, that is 9a squared, plus 7 squared, that is 49, plus 2 times 3a times 7 is 42a. And it equals to 697 plus a squared plus 42a. Here we subtract a squared from this equation. So here a square will get cancelled. Here we have 9a square minus a square is 8a square plus 49 plus 42a equals to 697 plus 42a. Here we have 42a on both sides of this equation, so 42a will get cancelled. After cancel 42a, this side of the equation left only if 8a squared plus 49 equals the other side of the equation left only with 697. So in total we actually found out that a squared plus 49 equals to 697. Here we subtract 49 from this equation and we get that 8a squared equals to 697 minus 49 is 648. So in total we found out that 8a squared equals 8a squared equals to 648. Here we divide this equation by 8 and finally get that 8a squared over 8 is a squared equals to 648 over 8 is 81. So in total we found out that a squared equals to 81. Here we'll take a root out of this equation and finally get that a equals to the square root of 81, that is 9. A equals to 9 units and it's 9. We only found out that 2x minus 7 equals to 3a, so to fit this equation here, 2x minus 7 equals to 3a. So 2x, here we add 7 to this equation and we get that 2x equals to 3a plus 7. So 2x equals to 3a. A is 9, so 3a is 3 times 9, that is 27 plus 7. 27 plus 7 is 34, so total we found that the 2x equals to 34. Here we divide this equation by 2 and find that x equals to 34 over 2 is 17. That is to say, the radius x of the semicircle is equals to 17 units in its length. Repeat again, we actually found out that the radius x of this semicircle is equal to 17 units in its length. Our task is to find out the area of this semicircle. We know that the area of any semicircle is equal to pi times the radius of the circle squared over 2. Repeat again, the area of any semicircle equals to pi times the radius of the circle squared over 2. So it is pi over 2 times the radius of the circle squared. The radius of this circle is x, therefore the radius squared is x squared. So in total, the area of our semicircle must be equal to pi x squared over 2. So it is pi over 2, x is 17. If x is 17, it means that x squared is 17 squared. So in total, we found out that the area of our semicircle equals to pi over 2 times 17 squared. That is to say, it's actually pi 17 squared is 289 over 2. So in total, we found out that the area of this semicircle, that is the area that we are looking for in this question, is equal to either 289 pi over 2 square units in size. In terms of numbers, it is equal to 453.96 square units in size. And again, in total, we found out that the area of this semicircle, that is the area that we are looking for in this question, is equal to either 289 pi over 2 square units in size. In terms of numbers, the area of this semicircle is equal to 453.96 square units in size. So we finished to answer on the second question. In the next step, we start with the lecture, we start with the repetition of the answer of the first question, and then repeat on the solution of this second question. In the first question, our test is to find out the radius of this circle. So in the drawing, we have a circle. This is line segment CP. This is equals to 12 units in length. This is line segment AP. This is equals to 4 units in length. This is line segment PB. This is equals to 4 units in length. This is angle CPB. This is equals to 60 degrees inside. Again, our test is to find out the radius of this circle. So, first of all, it is given as a question that AB is a straight line. So if you focus on the upper side of the straight line AB at point P, here the sum of the angles must be equal to 180 degrees according to all three. All three says that the sum of the angles from one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AB at point P? We have point P, we have here this angle is 60 degrees. Plus this missing angle, in total the sum of those two angles must be equal to 180 degrees according to all three. Therefore this missing angle must be equal to 120 degrees in size. And then again, this is the missing angle APC. This is equal to 120 degrees in size. In the next step, we join point C and A together by straight line, and we join point C and B together by straight line. By doing these constructions, we get the three triangles. Those two small triangles, the red triangle and the white triangle, and the big triangle, triangle ABC, that consists of two smaller triangles. So in the next step, we actually implemented the law of cosines on all those three triangles. On the red triangle, on the white triangle, on the big triangle ABC that consists of those two smaller triangles. So in the first step, we implemented the law of cosines in this red triangle, triangle CAP. Repeat again quickly on the law of cosines. The law of cosines is true in any triangle, so this is triangle ABC that could be any triangle. The length of side AB of this triangle ABC is A units, side BC equals to 3 units in its length, side AC equals to B units in its length. This is angle BAC, that equals to 30 degrees in its size according to definition. So in this triangle ABC that could be any triangle, according to the law of cosines, the following equation is true. C square equals to A square plus B square minus 2 times A times B times cosine theta. Again, C square equals to A square plus B square minus 2 times A times B times cosine theta. So we can actually implement the law of cosines in our green triangle APC. We implemented the law of cosines in this green triangle APC or ACP. According to the law of cosines, in this green triangle APC, the following equation is true. AC square equals to AP square plus BC square minus 2 times AP times BC times cosine 120 degrees. Repeat again, according to the law of cosines in this entire APC, the following equation is true. AC square equals to AP square plus CP square minus 2 times AP times CP times cosine 120 degrees. AC is the missing side, so let's say it is. So it is AC square equals to AP square. AP is 3, therefore AP square is 3 squared, that is 9. plus Cp squared. Cp is 12, therefore Cp squared is 12 squared, this is 144. Minus 2 times AP is 3, times PC is 12. Times cosine 120 degrees. And cosine 120 degrees is minus 1/2. So total, if you found out that AC squared equals to 9 plus 144, minus 2 times 3 times 12 times minus 1/2. Minus times minus is plus. So this expression in total is a positive expression. Here we have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. So this expression in total equals to 3 plus 12, that is 36. And we have here 9 plus 144 is 153. So in total we found out that AC squared equals to 153 plus 36 is 189. AC squared equals to 189. Here we took out all of the equation. We found out that side AC, the missing side AC, is equals to the square root of 189 units in its length. This is side AC, this is equals to the square root of 189 units in its length. Likewise, we implemented the law of cosines in this right triangle, triangle CPB. According to the law of cosines in this right triangle CPB, we choose angle theta as 60 degrees. So according to the law of cosines, in this triangle CPB, the following equation is to CB squared equals to CP squared plus PB squared minus 2 times CP times PB times cosine 60 degrees. But again, this triangle, the right triangle CPB, according to the law of cosine, the following equation is to CB squared equals to CP squared plus PB squared minus 2 times CP times PB times cosine 60 degrees. So it is CB squared. So CB is the missing side, so we leave it as it is. And it equals to CB squared. CP squared. CP is 12. Therefore CP squared is 12 squared, this is 144. Plus PB squared. PB is 4, therefore PB squared is 4 squared, this is 16. Minus 2 times CP is 12 times PB is 4 times cosine 60 degrees, that is 1/2. So in total, we should found out that CB squared equals to 144 plus 16 minus 2 times 12 times 4 over 2. So we have 2 in the numerator, 2 in the denominator, so 2 will get cancelled. And we have here minus 12 times 4 is minus 48. So this expression in total equals to minus 48. 144 plus 16 is 160. So in total, we found out that CB squared equals to 160 minus 48 is 112. CB squared equals to 112. Here we took out of this equation, we found out that the missing side CB is equals to the square root of 112 units in its length. This is the missing side CB, it is equals to the square root of 112 units in its length. In the next step, we define this angle CAB as alpha, and we implemented the law of sines in this big triangle ABC. According to the law of sines, in this big triangle ABC, the following equation is to CB squared equals to CA squared plus AB squared minus 2 times CA times AB times cosine alpha. Again, CB squared equals to CA squared plus CB squared minus 2 times CA times AB times cosine alpha. According to the law of cosines, this big triangle ABC, the following equation is to CB squared equals to CA squared plus AB squared minus 2 times CA times AB times cosine alpha. We already found out that CB squared equals to 112, and it equals to CA squared. CA squared equals to 189 plus AB squared. AB is 3 plus 4, that is 7, therefore AB squared is 7 squared, that is 49. Minus 2 times AC is equal to 189 times AB, that is 7, times cosine alpha. So in total, we should know that 112 equals to 189 plus 49 minus 2 times square root of 189 times 7 times cosine alpha. So we have 112 equals to 49 plus 189 is 238, and we have minus 2 minus times 7 is minus 14, so in total this expression equals to minus 14 times square root of 189 cosine alpha. Here subtract 112 from this equation. So in this side of the equation we have nothing, that is to say 0. While on the other side of the equation we have 238 minus 112 is 126 minus 14 times square root of 189 times cosine alpha. So here we have we added to this equation 14 times square root of 189 times cosine alpha. So we found out that 14 times square root of 189 times cosine alpha equals to 126. So here we divided this equation by 14. So 14 here we get cancelled, and left only on this side of the equation with square root of 189 times cosine alpha. While on the other side of the equation we have 126 over 14 is 9. So in total we found out that square root of 189 times cosine alpha equals to 9. Here we divided this equation by square root of 189. So we found out that cosine alpha equals to 9 over square root of 189. We substitute 189 by 9 times 21. So cosine alpha equals to 9 over square root of 9 times 21. We took 9 out of the root. The square root of 9 is 3. So in total we found out that cosine alpha equals to 9 over 3. Inside the root we left only with 21. We divided both the numerator and the denominator of this expression by 3. 9 over 3 is 3. 3 over 3 is 1, so in total here we left only with square root of 21. So in total we found out that cosine alpha equals to 3 over square root of 21. And again, in total we found out that cosine alpha equals to 3 over square root of 21. TA is the abbreviation for trigonometric identity. We have the trigonometric identity that says that sin square alpha plus cosine square alpha equals to 1. Here we subtracted cosine square alpha from this trigonometric identity, and found out that sin square alpha equals to 1 minus cosine square alpha. Here we took out of this equation and found out that sin alpha equals to the square root of 1 minus cosine square alpha. We already found out that cosine alpha equals to 3 over square root of 21. Cosine alpha equals to 3 over square root of 21. So copy this equation here. So we square this equation, and we found out that cosine square alpha equals to 3 squared is 9 over square root of 21 square is 9. Square root of 21 square is 21. So we found out that cosine square alpha equals to 9 over 21. Now we can substitute cosine square alpha, this equation, by 9 over 21. We did it, and we found out in total that sinus alpha equals to 1 minus cosine square alpha, that is 9 over 21. Here we multiplied 1 by 21, and then we divided by 21 in order to have a common factor with this number. So this 1 times 21 minus 9 over 21. Sinus alpha equals to the square root of 21 minus 9 over 21. 21 minus 9 is 12 over 21. We divided both the numerator and the denominator of this number by 3. 12 over 3 is 4, and 21 over 3 is 7. So in total we found out that sinus alpha equals to 4, and the square root of 4 over 7. The square root of 4 is 2, so inside the root we left only with 7. So in total we found out that sinus alpha equals to 2 over square root of 7 units. Again, sinus alpha equals to 2 over square root of 7 units. And we already found out that CB equals to square root of 112. In the next step, we implemented the law of sines in this triangle ABC. Please click here on the law of sines. The law of sines is true in any triangle. So this is triangle ABC that could be any triangle. Triangle ABC is described by this circle. The radius of this circle that blocks triangle ABC is R. So, in this triangle ABC, AB equals to 3 units in the stripe, side AC equals to B units in the stripe, side BC equals to A units in the stripe. This is angle BAC that is equals to capital A degrees inside according to our definition. This is angle ABC that is equals to capital D degrees inside according to our definition. And finally, this is angle ACB that is equals to capital C degrees inside according to our definition. So, in this triangle ABC that could be any triangle, the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. and R is the radius of this circle that belongs to triangle ABC. Again, according to the law of science, this triangle ABC that could be any triangle, the following equation is to A over sinus A equals to B over sinus B equals to C over sinus C equals to 2R. Again, R is the radius of this circle that belongs to triangle ABC. So we can implement the law of science in our drawing. This is triangle ABC. Triangle ABC is inscribed by this circle. Why triangle ABC is inscribed by this circle? Because of the fact that all the three vertices of triangle ABC lie on the circle itself. Therefore, triangle ABC is definitely inscribed by this circle. So, we take alpha here. So we have, according to the law of science, CB of sinus alpha equals to 2R. Again, according to the law of science, this triangle ABC, the following equation is to CB of sinus alpha equals to 2R, and R is the radius of this circle that belongs to triangle ABC. And again, the big triangle ABC, according to the law of science, the following equation is to CB over sinus alpha equals to 2R. We already found out that CB equals to the square root of 112 and sinus alpha equals to 2 over square root of 7. Again, CB equals to the square root of 112 and sinus alpha equals to 2 over square root of 7. So here we substitute 112 by 16 times 7. So it is 112 is 16 times 7 divided by 2 over square root of 7. We moved square root of 7. First of all, the square root of 16 is 4. So inside the root we left only 7. So this expression equals to 4 times square root of 7 divided by 2 times square root of 7. We moved square root of 7 to the numerator and 2 to the denominator. So we found out that 4 times square root of 7 times square root of 7 over 2 equals to 2R. 4 over 2 is 2. So this expression in total equals to 2 times square root of 7 times square root of 7 equals to 2R. Here we divided this equation by 2, so 2 will get cancelled on both sides of the equation, and we left only the square root of 7 times square root of 7, that is R. Square root of 7 times square root of 7 is 7, so in total we should know that the radius that we are looking for in this equation, this is the radius of this circle, is equal to 7 units in its length. So we finish to repeat on the solution of the first question. Next step, I repeat on the solution of the second question of this lecture. In the second question, our task is to find out the area of this semicircle APB. So in the drawing you have semicircle APB. This is line side AC, this is equals to 7 units in itself. This is line side PC, this is equals to 21 units in itself. This is line side PQ, this is equals to 16 units in itself. This is again CPQ, this is right angle. Again, our task was to find out the area of this semicircle APQB. So, first of all, we know that we define the radius of this semicircle as x. Okay. So, the radius is x, therefore the diameter AB is 2x. AB is 2x, AC is 7. Therefore, let me say that CB equals to AB, that is 2x, minus AC, that is 7. So, total CB equals to 2x minus 7, it's in its length. Again, CB equals to AB minus AC. So CB equals to AB, that is 2x, it is the diameter of this circle, minus AC, that is 7, according to what is given in the question. So in total, CB equals to 2x minus 7 units in its length. In the next step, we completed this semicircle to a circle. Then we extended SLPC by side line until it touches the circle. We define the touching point of the extended SLPM. We define the touching point of the extended SLPC with this circle. This point is point M. We define the length of line SCM as A. So here we can implement almost 65 in our drawing. Repeat quicker, almost 65. All 65 is 2 in any circle, so this circle could be any circle. So in any circle, if called AB intersect with called CD is 0.0, then the following equation is to AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. Repeat again, in the drawing we have a circle, this is called AB that intersects with called CD at point O. Again, called AB intersects with called CD at point O. So this drawing, the following equation is to AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can implement Rule 65 in our drawing. Now because in our drawing, this is called AB. It intersects with called PM at point C. Again, called AB intersects with called PM at point C. So all the requirements of Rule 65 are satisfied. Therefore, we can implement here Rule 65. Repeat again. Now, drawing, called AB intersects with called PM at point C. Therefore, according to Rule 65, the following equation is to AC times CB equals to PC times CM. Again, AC times CB equals to PC times CM. AC times CB equals to PC times CM. This equation is the implementation of Rule 65 in our circle. AC CA is 7 times CB. CB is 2x minus 7. And it is equals to PC, that is 21, times CM, that is A. So in total, according to Rule 65, the following equation is for 7 times 2x minus 7 equals to 21A. Here we divided this equation by 7, so here 7 will get cancelled. In the other side of the equation, 21 over 7 is 3. So in total, we found out that 2x minus 7 equals to 3A. Here we added 7 to this equation, and finally found out that 2x equals to 3a plus 7. In the next step, we join points Q and M together by side line. By joining points Q and M, we created the right angle QPM. Actually, we created the right angle QPM. So this is triangle QPM, the subset called MQ. Triangle QPM, subset called QM. And it's equal to 90 degrees in size. So here we can implement Rule 5 in our drawing. Speed quickly on Rule 5. According to Rule 5, any triangle is equal to 90 degrees in size must subtend on the diameter of the circle. This is triangle MAN is equal to 90 degrees in size, and therefore triangle MAN must subtend on the diameter of the circle. Triangle MAN subtend on chord MN, and indeed chord MN is the diameter of the circle. So according to Rule 5, any triangle is equal to 90 degrees in size must subtend on the diameter of the circle. So now we're drawing. This is triangle MPQ. Is equal to 90 degrees inside, and therefore it must subtend on the diameter of the circle. Triangle MPM, triangle MPQ subtend on chord QM, and therefore according to Rule 5, chord QM must be the diameter of the circle. So the diameter of the circle is 2x because the radius is x. So chord QM must be equal to 2x units in itself because of the fact that this is the diameter of the circle. So in the next step, we implemented the Pythagorean on the right side QPM. According to the Pythagorean theorem, in any right angle, the square of the hypotenuse equals to the sum of the source of the perpendiculars. So in this right angle MPQ, according to the Pythagorean theorem, QM squared, that is the square of the hypotenuse, equals to PQ squared plus PM squared. But again, this right angle PQM, according to the Pythagorean theorem, QM squared is the square of the hypotenuse equals to PQ squared plus PM squared. QM is 2x. This is the diameter that is 2x. So therefore QM squared is 2x squared. And it's equals to PQ squared. PQ is 16, therefore PQ squared is 16 squared, that is 256, plus PM squared. PM in total is 21 plus 8, therefore PM squared is 21 plus 8 squared. So in total, according to the Pythagorean theorem, this side right angle PQM, found out actually the 2x squared equals to 256 plus 21 plus 8 squared. We only found out that 2x equals to 3a plus 7. So we substitute 2x by 3a plus 7, therefore 2x squared is 3a plus 7 squared equals to 256. If we open the brackets of this expression, 21 plus a squared equals to 21 squared, that is 441, plus a squared plus 2 times 21 times a, that is 42a. So we also open the brackets of this expression. So we have 3a plus 7 squared equals to, here we have 256 plus 441 is 697 plus a squared plus 42a. And again, in total we should remember that 3a plus 7 squared equals to 697 plus a squared plus 42a. We open the brackets of this expression also. 3a plus 7 squared equals to 3a squared, that is 9a squared, plus 7 squared, that is 49, plus 2 times 3a times 7, that is 42a, and it equals to 697, plus a squared, plus 42a. Here we have, we subtract a squared for this equation, so in this side of the equation, a squared will be cancelled. Here, 9a squared minus a squared is 8a squared, plus 49, plus 42a equals to 697, plus 42a. Here we have 42a on both sides of the equation, so 42a we get cancelled. After we cancel 42a, in this side of the equation we have, this side of the equation we have to leave 3a squared plus 49, and on the other side of the equation we have to leave 697. So total we should know that 8a squared plus 49 equals to 697. If we subtract the 49 from this equation, we find out that 8a squared equals to 697 plus 49 is 648. So 8a squared equals to 648. Here we divide this equation by 8 and we found out that 8a squared over 8 is a squared, and 648 over 8 is 81. So in total, we found out that a squared equals to 81. Here we took out all of this equation, and we found out that a equals to the square root of 81, that is 9. So a equals to 9 units, and it's 9. But we already found out that 2x minus 7 equals to 3a. Therefore, so here we add 7 to this equation, and we found out that 2x equals to 3a plus 7. So 2x equals to 3a. A is 9, so 3a is 3 times 9, that is 27, plus 7. So in total, 2x equals to 27 plus 7, that is 34. 2x equals to 34. Here we divide this equation by 2, and we found out that x equals to 34 over 2, that is 17. So we found out that the radius of this semicircle x is equals to 17 units in its length. Our task is to find out the area of this semicircle APQB. APQB. We know that the area of any semicircle equals to pi times the radius of the circle squared over 2. Therefore, the area of this semicircle must be equal to pi times the radius of this semicircle squared over 2. The radius is x, therefore the radius is x squared. So I can find out that the area of our semicircle, that is the area that we open for this question, it is equal to pi x squared over 2. X is 17, therefore x squared is 17 squared, so it is pi times 17 squared over 2. So it is pi over 2, and 17 squared is 289. So in total, we should find out that the area that we are looking for this question, that is the area of this semicircle, it is equal to either 289 pi over 2 square units in size, or in terms of numbers, the area of this semicircle equals to 453.96 square units in size. Okay, thank you very much.